And if you have any messages, any questions or comments that you'd like to make during the session, just go ahead and put them in the chat box down in the bottom right of the GoTo training control panel. I'll do my best to pay attention to those and try to answer throughout. But if it starts to lag behind, I might have to come back at the end. So, and if somebody asks a question and you know the answer, feel free to jump in there. That sometimes is a little bit more efficient that way. So today we're going to be talking about an introduction to Metasploit. The goal here is to kind of have a bird's eye view. We've only got an hour or so, so obviously we can't really deep dive into Metasploit, and there's a lot of stuff we can get into. But my goal is to provide you guys with an overview of what it is, what Metasploit is at its core, how it works, why you should use it, and then hopefully by the end of it, you'll kind of have an idea of where you can go, what it's useful for, what you can do with it, that kind of thing. So just to get started, and now my slides aren't progressing. Woo, back. There we go. So my name is Nathan Sweaney. I'm a senior security consultant with Secure Ideas. Been with the company for about 2.5 years. We're an independent security consulting firm. Our consultants are spread around the country. We have representatives in Florida, North Carolina, Utah. Where am I? I'm in Oklahoma, based in Tulsa, Oklahoma. I guess I should read the slide maybe. Prior to Secure Ideas, I was in the point of sale industry for about 8 years, dealing with PCI, credit card compliance, and some other compliance initiatives there. At Secure Ideas, we focus on a wide range of security testing. Our primary focus is penetration testing, but we also do just general consulting. We do architecture reviews. We do a lot of training, that kind of thing. And then there's my contact information. We try to put a lot of focus on training. That's for customers that pay us, and then also just for the community at large. And so if you ever have a question or something that we can help with, even if you're not a customer, if you've never done stuff with us, shoot me an email if I can help. And if I don't know the answer, I at least might be able to forward you to somebody who does. So Metasploit. To really understand the value of Metasploit, we kind of need to know a little bit of why it exists and some of the history. I'm going to go through this pretty quickly because I don't want to spend too much time. But if you've never heard of Metasploit, kind of here's how we got to where we are today. In the old days, pen testing was kind of the wild, wild west. There were lots of exploits, a lot of systems that were poorly written, a lot of services buggy for various reasons. And so everybody was out there making their own exploits, doing their own thing. The problem is it was really ugly the way it was done. One guy would find a bug in a system and he would write an exploit to target for that specific vulnerability that he has in that specific use case for that specific test to demonstrate that specific type of risk. There was no consistency between people. One person did it one way, another person did it another way. One guy wrote stuff in C, another guy wrote stuff in Perl, another guy was doing it in Python, and just whatever happened to be. There was no standardization as far as how certain things are done or not done in each case. Different proof of concepts were written, just like I said, for the specific use cases based on what you're trying to accomplish. And there ended up being a lot of code reuse. So if I'm trying to write an exploit for this particular system here now, in 2 weeks, I might be doing a similar system with a similar vulnerability, but I had to completely rewrite it. The people that were really advanced kind of had their own libraries and they would, import their own stuff or maybe reuse their own code. But there was just no consistency to it. You also had a lot of different repositories and private collections. You had different hacking groups that would have their own little private collections of exploits. Some of those were public, some weren't. A lot of times somebody would write something and just dump it on a mailing list for everybody to use. Other times you kind of had to build this list of contacts and people you knew who worked in different areas in order to have different types of exploits for different things. There was also the issue of questionable sources. So you may, do some internet searches and find exploits out there, or you may be provided an exploit from somebody you know or somebody you've heard of. But how well do you really know that person? How well do you know what they've put in it? So what you have to do is go through and research and look at every bit of the code and figure out, okay, what is this actually doing? How do I make it work for me? And how do I make sure it's not doing something I don't want it to do? It's very easy to take advantage of people in that situation. So all of this together ended up being fantastic for attackers because there's lots of vulnerabilities, lots of exploits, lots of stuff you can learn, but you got to have time to do it. And for a in a commercial scenario where you're providing a penetration test or you're trying to defend your network, you don't necessarily have all the time in the world to try to break this one specific thing to demonstrate the risk. And the attackers have basically unlimited time. So what ended up happening then is, as part of an assessment, you may say, hey, here's a specific vulnerability we found. We're pretty sure it's exploitable, and if we had enough time, we could probably demonstrate that. But we really can't say for sure because we ran into these constraints, and so you'll just have to kind of figure out the actual business risk on your own. That kind of defeats the point of the penetration test to some degree. So in about 2003, H.D. Moore, quite the young man at the time, kind of got frustrated with the way this works and thought he had a better way of doing it. So he put together something he called the Metasploit framework. He described it as a platform for writing, testing, and using exploit code. He posted this to a mailing list. I think it was in October of 2003. And it was really, when it first came out, it was, people kind of like, what? Well, that sounds interesting, but really, how are you going to do this? And what's it going to be like? It was, I don't know that it was really taken that seriously in the beginning. At least I don't recall it being. But it was, obviously it's proven to be pretty successful. Some of the goals that HD lined out in that initial email was that he wanted it to be free and open source. That's something he's always pushed, and we'll talk about that a little bit more later. He wanted it to be easy to use, so that the idea is that anybody who needs to go in here and demonstrate the exploitability of some particular vulnerability could do that without having to be an expert in that particular language or that particular system. It also should be flexible and extensible. The idea being that if I write an exploit for this particular system, I don't have to rewrite the entire thing for another system. A lot of the code is reusable. All I have to do is modify or add a new payload for the specifics of that vulnerability. And then also be consistent so that, again, it makes it easier to share and move things around. That first version was written in Perl, and when it was released, it only had 8 exploits. Trying to think about that now, it seems pretty minuscule. I think there was an IIS exploit and I don't remember which, an FTP server and something on SSH. But the core of it was written with growth in mind. It was written to be, like I said, extendable, and it was very well organized. Over the years, Metasploit continued to grow. 2.7 was a very popular version of Metasploit when that came out. I think at its height, it had about 150 exploits, maybe a little bit more. That was used for a long time. And then up until about 2007. In 2007, they completely redid Metasploit and they released version 3.0. That was written in Ruby for several reasons. One of them, I had a firmware coworker that used to say that Perl is a write once, read never language. And I can attest to that. Anytime I've had to write stuff in Perl, I can usually figure out how to do what I need it to do. But then if I ever have to come back to it and reuse it or modify it, I have to start all over because I can never read what I actually wrote. I think there's probably some Perl experts out there that are would challenge that, but they're few and far between. Ruby was becoming more popular. I think it came down to Ruby and Python, and they chose Ruby for another number of reasons. In 2009, Metasploit was acquired by Rapid7. That was somewhat of a contentious situation. Up until that point, Metasploit had continued to grow. I think at the last comment I saw, it had over 700,000 lines of code, which they advertise as being one of the world's largest Ruby projects, if not the largest project. But when Rapid7 came in, things changed a lot. And as well, we're going to see, it actually ended up being really well for the good. Up until that point, Metasploit was kind of the baby of HD Moore. There was a number of other developers, a number of people that worked on it, but HD was the one that really pushed it. The problem is he also had a full-time job working for another company. Metasploit was just his side gig that he did for fun. So every time there was a new release, every time there was major updates, he's the one that went through and did all the checking, did all the testing to make sure it didn't break stuff and whatnot. He's the one that really pushed the project forward. When when the project was bought by Rapid7, the trademarks and all that, the community kind of threw up a fit saying, "Oh no, what's going to happen? They're going to commercialize it. They're going to kill the open source version." Some people pointed back to like what happened with Nessus years ago, and there was just a lot of concern about it. HD stood up and he basically stood before the community and said, "Here's what's going to happen." He said, "I've always promised that this would be free and open source, and I stand behind that. It will be. Rapid7 has made a commitment to push that forward and provide resources to make it better than ever. And HD made the promise that should Rapid7 ever discontinue the open source version, that he would step away and that he would continue the development, through other means." So what we saw after that period in 2009 was just an explosion of growth. The Rapid7 committed just unimaginable resources to the project. For testing, for further development. There's a lot of things that, well, this never quite worked right, but nobody had the time to spend putting onto it. Rapid7 was able to commit developers to do those things. A lot of exploits worked well in some systems, but not on other systems. They put forth the resources to be able to test it out on various systems and figure out why things weren't working. So currently, what we see as of July 2015, actually this was of I think yesterday that I did an update. We've got almost 1,500 different exploits within the system. That's a huge step up from the 8 we started with. And then you can see the different other types of modules there. We're going to talk about in a little bit more detail here in a few minutes. So let's jump in. The first thing we need to figure out is how to get started. What do we do? Where do we go from here? Where do we start with Metasploit? The easiest thing, there's a number of ways you can do it. You can actually go grab the source code because it's open source. You can go grab it, load it all up yourself, and make it work. You can do that. It's a little bit of a hassle. It's become much more complex than it was 3 or 4 years ago, 5 or 6 years ago even. The easiest way to get started, there's 2 ways. So one way is to go to Rapid7 site and download it. We've got the link right there. Now, the thing to be aware of is that Rapid7 didn't buy this purely to update the open source version. Their goal was to provide commercial products that were built on top of the open source framework that then they could sell. And they've done that, obviously. When you go to this website to download it, the first thing you're going to see at the top is links to Metasploit Pro or the Metasploit Community Edition. Those are both paid versions that provide additional features. They make it a little bit more user-friendly to get started. If you scroll all the way down to the bottom of that page, you'll see a link where you can download the framework. I think it's just called the Metasploit framework. That's free. There's no, I don't even think there's a sign-in anymore. At one point you had to go in and sign in, with your email address or just put a fake email address and click next, but they've taken that out as well. Now you just download it. It is a binary file that you have to execute and go through the installation process, and it'll do a number of things. If you're relatively new to Linux or not really familiar with installing stuff or not really sure where to go, the easiest thing is probably to get a live CD, and the best one to get started with is Kali Linux. There's the download there. Kali Linux is the son or grandson of a distribution called Backtrack Linux, and it was designed to be a penetration testing live CD. Nowadays, I don't know anybody that uses it as a live CD. Most people download the virtual machine, or if they do download the live CD, it's just so they can install it in a virtual machine. But if you go to the website there, you can download that directly. It's got a ton of pen test focused tools, a lot of just security tools in general. But the best part of it is the Metasploit is built in. It's already installed. The database is configured. Everything's set up and ready to go. And it also, the updates are very easy to do. Just another note there. There are other versions. You can actually, Metasploit will run on Windows. There's a Windows binary that you can download and install. I don't know what the current status of that is. In the past, there were parts of it that didn't work as well. Different things didn't work, especially in certain versions of Windows. You're free to try that, but I would recommend against it, just because the hesitancy in the past of some, everything may seem to work, but certain payloads may not work and may not tell you that they didn't work necessarily. So Kali is definitely the way to go. There's also, if you plan on going to DEF CON next week, Kali 2.0 is scheduled to be released, I believe, at DEF CON. I know the formal release on the website is supposed to be August 11th, which will be a couple of days after DEF CON, but I believe they're going to have pre-release versions that are available. So if you're wanting to try this out and play with it, by all means, go download it. But if you're planning on waiting a week or two before you really do anything, you might just wait till 2.0 is released. There's a number of what I call point-and-click editions also. As I mentioned, Rapid7 kind of commercialized the product. So you've got Metasploit Pro and Metasploit Express, just different levels of functionality there in those. But those are both commercial that you pay for. You've got the Metasploit Community Edition, which is free, but it's not. It's a limited edition of Metasploit Pro built on top of the framework. So it's designed to be more user-friendly, but ultimately the goal is to push you towards Metasploit Pro. You also got some other third-party options here. Armitage and Cobalt Strike are basically the same as the Metasploit Community and Metasploit Pro, just designed by a third party, again, built on top of the Metasploit framework. All of these add some features and functionalities. They basically try to make it easy to use for someone who doesn't know what they're doing. It's designed to streamline the process, etc. The problem is, if you start with one of these versions, you're going to have a harder time understanding what's really happening behind the scenes. You're going to have a harder time. It's designed to kind of obfuscate you from the actual use of certain modules and how payloads and stagers and whatnot work together, which we're going to talk about in a few minutes. If we get to the end of this webinar and you're still like, I'm scared to try it, by all means, feel free to try one of these, the kind of the point and click editions. But if you don't, if you're willing to jump in and try it from the command line, what you're going to find is that branching out, trying new things is going to be much easier. You're going to be much more comfortable with what you know. And if you get to the point of actually trying to write your own modules and do your own customizations, it's going to be much easier. So command line access. Like I said, this is generally, in fact, I've tested out some of the point and click stuff. I've never actually used one, for any significant amount. msfconsole is the primary command that we're going to use. Up until last month, actually, there were 4 different. I think there's some others, but there were 4 main command line tools. We'll come back to msfconsole. MSF Payload was designed for creating single-use standalone payloads. So I want to create an executable file of some kind, or I want to create a jar file or a PDF or whatever. You could do that directly with MSF Payload, and it would just create a single file that then you could take and move to a victim system or whatever. MSF Encode was designed to allow you to obfuscate payloads. So, for instance, if you create a standard payload with default options, most signature-based antiviruses are going to detect it. They're going to say, hey, I recognize that snippet of code that's there, and throw off alerts or quarantine your file. So what MSF Encode does, or did, is actually take the file, the payload that you've created, obfuscate it a little bit, change the coding behind the scenes so that the signature of that file is considerably different. There's all kinds of different options and stuff with MSF Encode that allowed you to do different ways of trying to obfuscate the file. Both of those, both MSF Payload and MSF Encode, have been deprecated as of June of 2015. They were actually deprecated maybe a year ago or several months ago, but they're finally being removed from the system as of last month. They've been replaced with MSF Venom, which basically does everything that I've just talked about, plus some additional features. We're not really going to go into much detail with that today, but that's something you can explore. MSF CLI originally was a command line interface. msfconsole was designed to be used by a user sitting at the console typing commands in, more of an interactive type scenario. MSF CLI was designed to be used in scripting. So if you wanted to set something so that when one thing when one thing happens, it automatically runs this script and uses Metasploit to launch a payload or whatever, that you would do all that with the CLI. That's all been deprecated now, and all the functionality for that has been introduced into msfconsole. So for the most part now, unless you're using the point and click edition, the only real executable you'll use is msfconsole. So jumping in, this is what it looks like. You notice I'm running on a Kali system there. It's in the top left. I type in msfconsole, and like any good, command line security tool, you're going to get some ASCII art. I don't remember how many there are. There's probably 10 or 15 different little images. Some of them are funny, some of them aren't, that just pop up there that have ASCII art. The next couple lines you'll see right there in the middle where it has frustrated with proxy pivoting. That's just a short little advertisement that Rapid7 has thrown in for Metasploit Pro. You'll see those in a few places. They're pretty unobtrusive. That was one of those things that everybody threw a fit when that got thrown in, and then after a week or two, everybody just learned to ignore it and nobody cares. But that's part of the price for the resources that they've thrown in. Moving on down a little bit, you'll see the specific version of Metasploit. Notice this one is 4.11.4, updated, July 14th of 2015 was the last major update. And then we've got a list of all the different modules that are built into Metasploit in this particular version. So it shows us 1,467 exploits, 840 auxiliary modules, and we'll talk about the rest of these here in just a moment. And then at the very bottom, we have the MSF prompt. This is basically our Metasploit prompt that we can then enter other commands and go from there. So like any good tool, when you don't quite know what it does, the first thing you do is type help or man, but there's no man page here. So we just type help for this. One of the first things you'll notice when you type help is just the page scrolls. It scrolls and scrolls. You can move up and down and see what's there. There's a surprising number of commands available. That some of them are a little bit more obtuse, might not be quite very clear, but they're very well documented. There's also, you can type, usually I believe you can type help and then a command, or command and then help, I don't remember which, and it'll show you more detail about that specific command. I'm not going to go through each one of these commands here. A lot of them are pretty straightforward and you can kind of walk through it yourself and play with it, but that's one of the first things that I would recommend. Once you get Metasploit up and running, type in help and just start reading through the commands, see what it does, learn how they work, stuff like that. Instead of walking through all the little minutia of the system, what I wanted to do is really jump in and say, okay, let's exploit something. Let's show you how to take a system, gain access to it, and demonstrate, what you can do there. And the reason for that is, I've read books, I've read blog posts, I've done that kind of stuff on various tools, and still felt kind of like I'm not quite sure I know what I'm doing. But once you actually see it, once you watch an example of, okay, I click this, I type this, and boom, this happens, and then you go repeat those steps and do it yourself, then okay, I can do this. And then trying to go from there and say, okay, what if I do this instead of this? What if I try this instead of this? It gives you kind of a foothold into the system to explore. So hopefully this will help with that. Before we can do that, we need a little bit more terminology. I talked about the different types of modules available before. The first type of module is exploit modules. This is something that takes advantage of a vulnerability of some type. There's tons of different types of vulnerabilities out there, whether it's a client server type system, or whether it's a web application or whatever. Anything that has a vulnerability that can be attacked, the actual code that does the attack is called the exploit. And obviously there's more of those than anything else. The next section is called payloads. A payload is something that actually does something on the victim system. So once we've exploited it, and now we have ability to do something on that system, then we use a payload to actually do that something. That could be grabbing hashes so that we can pull them back and try to crack them, or use past the hash. Maybe our payload is to set up a VNC server so that we can connect back into it. Another example would be maybe create a new user and add it to an administrator group. Those are all examples of payload modules that have been created to be used. Obviously, there's 432. There's a lot of options. Some of those are specific. A lot of those are specific to specific types of systems. Some of them are a little bit more general. Encoders, just like we talked about with MSF encode, encoders are designed to provide obfuscation. So you may run into situations where a certain attack doesn't work because of something in line. Maybe there's some type of IPS system or a web app firewall or some type of gateway antivirus or something that is blocking certain attacks. Encoders are designed to basically try to obfuscate the attack and bypass some of that. Auxiliary modules, these are non-exploitative modules. We'll look at some examples of these here in a little bit, but basically these are going to be scanners that look for certain types of systems or certain ports available on a network. These might be discovery type modules that basically scan a certain system and look for certain certain details. There's a wide range of those. The post modules are primarily information gathering. So these are used after you've exploited a system, you've gained access to it in any way. Then you can run a post module that will try to pull the information from that system. Maybe trying to pull network details, or maybe enumerate lists of users. For example, there's a post module that does, I can't remember the exact name of it. I think it's enum SNMP. And what it does is it tries to enumerate an SNMP string on that system itself. So it gives you an idea. So one of the questions that always comes up kind of about this time is, you lost sound. Can anybody else hear me? Got it back. Okay, great. So one of the questions that always comes up about this time during the discussion is, why are we doing all this for bad guys? Why are we providing all these tools, making it easy for bad guys to exploit our systems? The thing is, the bad guys can already do it. Everything that's in Metasploit, 90% of what's in Metasploit is freely and easily available and accessible out there. The thing is, you have to have time to go and research it and figure it out and find out how it works and to do it. So we have to assume that the bad guys are already doing that. Remember, to really make a sound decision about business risk, we have to assume that our attackers have almost infinite amount of time and an almost infinite amount of resources. Obviously, that's not true, but that's where we have to start, and then we have to determine how likely certain things are to do. So what Metasploit does is it kind of levels the playing field. It gives us, as the good guys, as the defenders and as the pen testers, to simulate what the attackers are actually capable of, what they can actually do, without having to spend the considerable amount of resources and time to do the same thing, to go and do all the research and whatnot. The other thing that we've seen is, especially with malware, is we've seen kind of a commoditization of roles. So one guy will go out and actually develop certain exploits, and he might lease those or sell those to another guy who's developing the command and control software, and another guy who's actually trying to spread the system out there, and another guy who's managing the botnet. So we have all these different roles and people doing different things, and they're specializing in their area, which makes them much more efficient. So again, Metasploit kind of levels the playing field for us to be able to assess our networks successfully. Moving down the list, Meterpreter is a very special payload. It's basically an advanced payload that runs in memory on the target and allows us to do a lot of different things. I said before that a payload does something on the target. Meterpreter is kind of an all-in-one payload that does a whole bunch of different things. It's also extendable so that we can load plugins into Meterpreter that allow us to do even more. And we're going to look at that very specifically here in a few minutes. And then plugins, like I just mentioned, basically extend other forms of functionality to add more stuff to Metasploit. There's a number of plugins built in. There's a lot of modules built in. There's also a lot of people who write their own modules or write their own plugins. Sometimes these aren't always rolled back into the framework. Sometimes it's just because that person who writes it doesn't want to take the time to coordinate with Rapid7 and make it happen. Sometimes it may be because whoever wrote it didn't take the time to meet the appropriate standards and rules that you have to make a plugin be accepted. There's all kinds of different things there. But if you follow the InfoSec crowd on Twitter, keep up with blog posts and whatnot, you'll often find people that release different plugins or modules that are very useful that maybe not be part of the core program. So let's exploit something. Just as a demonstration, and partly because I already had it up and running and useful, I'm going to use a Windows XP machine. Now, the first thing that I know everybody's saying is, wait, nobody has those, right? Because they've been unsupported for well over a year, a year and a few months. Unfortunately, 2 weeks ago was the first pen test I've been on ever that didn't have any Windows XP machines. The truth is everybody still has them. We were at a client maybe a month ago that had 100, maybe 200. I don't remember. It was a huge network of Windows XP machines. Everybody has plans to remove them, but a lot of people just aren't there yet. So unfortunately, these are still out there. The other thing is, and what's funny is a lot of times the XP machines are out there because, yeah, scary, it is. Part of the reason that these machines are out there is because they're designed to be used in this specific system, and whoever developed the software hasn't updated it, or maybe they can't update it, or maybe the software is no longer available. This is really common in like healthcare environments where this particular healthcare device was written to use Windows XP, and oh, by the way, you can't patch it because you might break stuff, and so now it just sits out there on the network. You also have a lot of point of sale systems that are in a similar situation. So what ends up happening is a lot of these, like I said, are unpatched. So one of the most most exciting to see vulnerabilities on an unpatched Windows XP system is MS-08-067. This is a vulnerability in the server service that's basically used for for systems to communicate over the network. Primary time a user would use this would be for sharing files or accessing network shares over the network. If you're not familiar with how Microsoft does their patching and vulnerability naming, MS-08 stands for, obviously it's Microsoft, and 08 stands for the year it was discovered. So this was discovered in 2008, about 7 years ago. 067 is the sequential number of vulnerabilities of throughout the year. So this was the 67th vulnerability that Microsoft made note of in 2008. Most vulnerabilities, the really common ones, are, for at least all the ones from Microsoft, are noted by MS-08-067. So one of the questions that comes up often is, how do we know this is vulnerable? How would we find this particular system to know it's vulnerable? Or how do we know to use this particular exploit? I'm not going to go into a lot of detail there. That goes back to kind of the mapping and discovery phase. Generally, when we use Metasploit, or at least for me personally, we found specific vulnerabilities and we're moving on to the exploitation phase. There's a number of different ways to do it. A lot of different scanners. Nmap has what they call NSC scripts. That's an Nmap scripting engine. And those are different scripts that are designed to search for specific things. The great part about some of the NSE scripts is they're not really all that noisy. You can also use something like Nessus or Nexpose, a more full-featured vulnerability scanner that's just going to pound away at everything on the network and look for vulnerabilities. Those are very loud and quickly discoverable. The Metasploit also has some auxiliary scanners that we talked about, and I'll show you a few more here in a little bit, that do similar to what the Nmap NSE scripts do, is they search for different types of situations. There is an auxiliary scanner that looks specifically for MS-08-067, so that you can try to attack that. And for this example, we're going to use the Meterpreter payload that I mentioned before so that I can show you a little bit more detail on how it works. So the first thing we need to do from our command prompt is we need to know the name of the module. I'm really bad at remembering. There's certain modules that I use all the time, and so it's kind of easy to remember those. But even this one, like I never remember to type in the SMB. You can see in the middle of the screen there where it says exploit/windows/SMB/MS-08-067_net API. That's the actual name of this module. And every time I type that in, I always forget the SMB, and then I never can remember what it should be. So if instead at the command prompt or at the Metasploit prompt, you just type in search space MS-08-067, it'll pull it up. If you're using Kali, if you've got the database configured correctly and whatnot, like I said, with Kali, it's all built in. It's automatically configured. This is usually very fast in how it returns these. The first time you run it, it may have to build an index and take a little bit longer, but it's usually very responsive. It's also very helpful. They've done a really good job. Metasploit's done a good job of making things more friendly. So if you type in MS-08-067, it's going to find it. If you type in MS-08-067, it's still going to find it. So they do a pretty good job of helping you find what you're looking for. In fact, if you type in MSO8, you'll get a list. I don't remember how long it is, but you'll get a list of vulnerabilities that then you could scroll through and find the specific one you're looking for. I'm sorry, not vulnerabilities, exploits. So something to note also, I mentioned the name here, the exploit Windows SMB MS08067. That name kind of belays the structure of how the system is built. If you go to the command line and you just start looking through the Metasploit directory of where things are at, once you find the modules, you're going to find the exploit directory, and inside that you're going to find a Windows directory, and inside that you're going to find an SMB directory, etc. So they do a really good job of keeping it pretty organized and structured. You can also, they have tab complete. So let me, oh, hold on, I'll come back to that. A couple of things to notice on here, the disclosure date, it shows the actual date when the particular vulnerability was disclosed by the vendor, or if it was released as a 0 day on full disclosure or something like that, it'll show the date that was released, to give you an idea. The next thing, and this is maybe one of the most important things, is where it says rank. And notice this one is ranked as great. One of the things that Rapid7 did when they purchased Metasploit is to go through and really test out all of the exploits, and they set a certain set of standards in place for how new modules could be uploaded to the framework. And as part of that, they all have to be tested out very thoroughly against systems, and they come back with a ranking. And I can't remember what all the different rankings are. There's good, there's great, there's low. I can't remember what the others are, but basically these take in it takes a couple of things into consideration. One of them is the reliability, and by that I mean how likely is it that this exploit will work and not just fail. And then the other is the potential impact on the victim system. So there's some exploits that are pretty reliable. They work 80% of the time. But the other 20%, if they fail, they completely crash the system and it has to reboot. That's not a very good exploit, so that's going to get a lower ranking. Whenever you see great, you can be pretty confident. In this one, in fact, I would say, I'm thinking this through because I don't want to overstep. I think I could say I've never seen a great ranked exploit fail. Like, I think every one I've ever run has worked. It's entirely possible that there's some special cases out there where they don't. Obviously, they can never guarantee it 100%. But if you see great, they've taken the time to make sure that it's going to be pretty successful. Moving on. Where am I? The other way you can find a particular vulnerability, if you're not quite sure the name, if you don't know what to search for in Metasploit, is just Google it. If you have other details about the vulnerability or whatever, you can search for it. Let's say you've run a Nessus scan and it's come up with some systems that say, here, they're vulnerable to MS08067. Often in Nessus, down on the bottom right corner, it'll show you the details about the scan, and it'll tell you that an exploit's available in Metasploit. It'll tell you, here's some links to the different vulnerability disclosures about it. And oftentimes they'll link actually to the Rapid7 page. What we're looking at here is that Rapid7 has gone through all of the vulnerability or all of the exploit modules. In fact, I think all of the modules. And they've created a page that explains what it is. It shows the full model name there. You can see highlighted in the middle. It'll show the author. If you scroll down more, it'll show you the targets that it works against. It'll show you the ranking. And then I think there's some other dependencies and some other stuff like that at the bottom. But if you go to Google and search for MS08067, this page is the second result that's going to come up. And that's pretty common for a lot of vulnerabilities. Same thing, if you go and you look for a CVE number, oftentimes the Rapid7 vulnerability page will be the first one that comes up. So now that we know what exploit we're going to use the use command. It's up there in the very top line. I'm saying use exploit /Windows/SMB, etc. Again, tab complete works wonders. So if you are looking for something specific, you can type in use exploits. I wouldn't type in exploit/tab. You may have to double tab, I don't remember. Because what you're going to end up getting is, I guess if you hit tab once, it'll try to fill in if it can. If you double tab it, like a standard Unix system, if you double tab, it'll list all the available options. You're going to get 1,500 exploits available if you double tab after exploit. But you do /Windows/SMB, now you're going to get a list of maybe 10 or so, and you can scroll through there and figure out which one you want. Once you've loaded that, notice our prompt changes. So now instead of MSF, we have MSF space exploit and then the specific exploit we're using. If you were to load an auxiliary module or some other type of module, a post module, it would say MSF space auxiliary and then in parentheses that particular module name. So the next thing I do every time, no matter what, is I type in show space options. This is going to show me all the specific options available for that exploit. And I do that for a couple of reasons. One, I mean, I've run this exploit so many times that I could do it blindfolded, but I've also updated my system since then. And I don't know for sure if perhaps something in this exploit changed, and I don't want to just go run it blind willy-nilly without looking to see if maybe there's a different option this time. So I always type show options. The other thing is I want to make darn sure that I've typed in the right settings. So see here where it says our host, that's the target address. So we'll see here in a second, we're going to specify that remote host. I want to make sure if I've set that host that I actually set it to the system that I'm trying to exploit. I don't want to be targeting the wrong system. There's some other options there. The port, the SMB pipe, those are going to be the same for this particular vulnerability. Different exploits have different settings. So show options is very exploit specific here. And then we also have the target. If we typed in show targets, it would list a huge list for this particular. It's going to list everything that's available that could be targeted and could be exploited with this particular vulnerability. So you're going to get every different version of Windows XP, the professional and ultimate and enterprise. You're going to have all the different language, whether it's Dutch or Sweden or Chinese or whatever. And that scrolls quite a bit for this. Others, it'll come up and it'll say, here's your 4 different targets. With a lot of them, when possible, especially something like this that targets Windows XP, you could just leave it on 0 and it'll do automatic targeting. They've done a good job of making it so it figures out what it's supposed to do. Moving on here. So notice there at the top, we set the remote host, the R host, and it echoes it back to us. And then again, I type show options and I confirm that that was set. Moving on here. So the next thing we need to do is select the payload. Metasploit has 432 payloads available. I think that's actually more. I don't think I updated the screen. I think that's like 480. Payloads come in 2 different styles. There's either a single payload, which is basically just a simple self-contained one thing, one kind of thing. It executes a command. Maybe it adds a user, whatever. It's very basic. Doesn't do anything else. The other option is a stager and a stage. These always come together. And so a stager and a stage basically does, a stager, for example, connects back to us or sets up a server so that we can connect into it, something like that. And then the stage is what happens with that connection. And maybe it listens on, it sets up a VNC server. Maybe it sets up Meterpreter, which we're going to look at. Maybe it provides us, dumps a command shell back to us, something like that. So in this case, what we're going to do at the very top line, we're going to say set. We're going to set the payload option, and we're going to set to Windows/Meterpreter/reverse TCP. Again, this is organized just like we saw the exploit naming convention. So until you go into the file structure, inside the payload directory, you're going to have a Windows directory, and inside that, you're going to have Meterpreter, among other things. And inside that, you're going to have reverse TCP and reverse HTTPS and reverse HTTP, etc. Once we've set that payload, now we can say show options again, and notice our screen is different. We still have the module options there in the middle, but now towards the bottom we have the payload options, and these are options that are very specific to this payload. In this particular case, the exit function, that's never going to change. The lhost is basically the connection or the IP address on our local system that we want it to connect back to, and then also the local port. And the reason that is you notice that, so in this case, our stage is Meterpreter, but our stager is reverse TCP. That means that once the exploit runs, it's going to load the Meterpreter payload, and then Meterpreter is going to connect back to us. It's going to make a reverse connection via TCP. So what we need to do, we need to set the lhost to our particular IP address, and then we need to set the L port, as the port that we want to listen on and that we want them to connect back to us. 4444 is the default. I always recommend changing that. I always change it. Sometimes I use, something that, my PIN number on my bank card that I know nobody uses or whatever. If I happen to exploit your system, don't go look at the port that I use, by the way. I had a company one time that, I don't remember what the situation was, but we found out that they had alerts set up in their firewall for anytime anything connected on 4444, they got alerts because they had some attacker that got in and used the default. And so they were under the assumption that that's what Metasploit used. And so anytime they saw 4444, they freaked out and they thought that, they had a Meterpreter session running. I'm trying to remember the situation because we were using 4444 for something else unrelated, and they were convinced that it was Meterpreter. But short version, use a different port there. Sometimes this can also be useful if you have a restricted environment where only certain outbound ports are available. For instance, maybe they allow 443 outbound, but they don't do any content filtering or anything on it. Then you could actually set your port to 443 and then just make sure your local server can listen on 443. Moving on here. So once everything is set up, all of our options are set. Now we're going to type in exploit. You can also type in run. They do the same thing. Sometimes I forget one or the other and just type in whichever one I think of. And what you're going to see there in the middle where the blue stars are, you're going to see it starting the reverse handler. So when I exploit, it automatically starts a listener on 4444 on my IP address. And then it's going to auto detect the target. We talked about that. And it's going to come back and say, okay, we fingerprinted this as Windows XP, no service packs, or maybe 1, 0, or 1, and the language is English. And it's going to say, okay, the target's selected. Here's the specific exploit target. It's going to attempt to trigger the vulnerability. That means it's actually running the exploit at that line. And then the next line, when we see sending stage, that means our exploit was successful. And now it's downloading the stage, which, remember, is the reverse TCP. And as soon as we do that, now the stage is going to, I'm sorry, that's the stager. The stager is connected. Now we're sending Meterpreter, which is the stage, and then it's going to connect back to us. And then the very last line there, you see Meterpreter session 1 opened, and it shows it from this IP is connecting back to the other IP and the timestamp there. At this point, we now have access to that system. We're running on it. This is the point where you do your root dance and you get up and you cheer and you get excited, and then you sit back down and figure out what you actually have access to. By the way, if you haven't perfected your root dance or you don't have a clue what I'm talking about, that's something you need to work on before you really get too far into Metasploit. So let's talk about Meterpreter for just a minute. Meterpreter, as I mentioned, is an advanced payload. It basically runs in memory. So that what happens is that most AV, not all AV, but most of the antivirus systems out there, they don't always see something running in memory until it actually touches the disk. So when you download it, they see it when you save it to the file, or when you run it and access it from the file system, they see the on access scan. But when it's running in memory, if it hasn't come through through the browser or through something they're monitoring, they might not see it in memory. There's also ways you can obfuscate that for some of the AV that actually do. But for the most part, Meterpreter rarely gets caught by AV when you're just deploying it like this. Within Meterpreter, there's a ton of commands, just like there is with the base Metasploit. You can type in help, and you're going to see a huge wide range of things that you can do. Some of the commands, you can actually run commands directly on the OS. So, I showed you have the Meterpreter prompt there. You can type in CD, and it'll allow you to change the directory on the file system of your victim. If you type in LS, it'll show you. I think normally when you exploit MS-08067, you run an LS, you're going to get C:\Windows. It might be System32, I don't remember. What's interesting is that LS is not a Windows command, right? But Meterpreter actually does the interpretation for there. I think you can actually type in dir as well, and it'll recognize both and then go ahead and run that command on the system. So you can move files, remove files. You can actually cat files that are on that remote system so that you can see the contents of them, which is very useful. And there's a number of other commands there that you can explore and look at. There's a number of networking things you can look at. You can dump the ARP table that's going to show you all of the systems in the local network that our victim has connected to. ifconfig, I believe you can run ipconfig as well. I think those are interchangeable. We're will show you obviously the networking configuration of that system. Netstat will show you traffic going back and forth. The port forward is kind of neat. You can actually set up a port forward on that victim system so that then you can run other tools against the local network through that victim and kind of bypass their firewall. You can also do the same thing with route. You can set up a specific route from your system through that Meterpreter session so that then you can run just about whatever you want to on their network. There's functionality to upload and download files. Those are kind of finicky. I'm always hesitant to use those. That may just because in the past they didn't work very well and I haven't tried them recently. But I usually use that as a last resort when I have to. And then there's options there for recording keystrokes, taking screenshots. You can actually activate the webcam, turn on their microphone, a lot of stuff like that. Generally, those don't come into much use in a standard pen test that we do. But there's always use cases for those. They're also very useful in demonstrating to somebody, hey, this really is possible. This is what can happen. Obviously, if you turn on the webcam, you're going to have the light pop up on their laptop to tell them the webcam's on. And then there's a bunch of additional plugins. We'll look at a few of those in just a minute here. We're getting short on time, I know. So using Meterpreter, some of the commands here you can type in. sysinfo shows you information about it specifically. We can see that it's an x86, so it's not a 64-bit architecture. If I type get PID, it's going to show me the process ID. Get UID, it's going to show me who I'm currently running as. Notice in this case, because of MS-067, because it runs a system, we got system access. Whatever level of whatever the service is running as on the system, that's the level of access we have when we connect into it. Migrate is a useful command. There are sometimes we are able to exploit a service, but we want to be really cautious with it. We don't want to make it crash. And so before we do any other commands, we'll use migrate to migrate over to another running process. You can type PS and it'll show you a list of all the services or all the processes that are running. So then you can choose which process ID you want to migrate to. The other thing that's good for is sometimes there are certain things that might be easily detectable. So you might want to migrate to a process or service that's less detectable, so that if somebody is trying to do some incident response, they may not notice the other service that you're running on. Some other commands, they aren't listed here. Get system is a kind of an automated privilege escalation. It runs through a whole bunch of different privilege escalation exploits with the goal of trying to gain system level access. So if we exploited a vulnerability and now we're only running as a limited user, we might be able to run get system and escalate privileges. The get system works really well on Windows XP. It works okay on Windows 7 if there aren't patches done. If you have a fully patched system, get system probably isn't going to work for you. With the most recent versions of Windows, especially 8 and 8.1 and 2012 and 2012 R2, it's really hard to escalate privileges. There are mistakes that people make that allow it to happen, but it's not nearly as easy as it used to be. There's also a shell command here. We can type in shell and it'll drop us directly to a C prompt on Windows. There's a hash dump command that will dump the contents of the SAM database that lets you then try to crack those hashes or use them for pass the hash or whatnot. I mentioned plugins. There's a number of plugins that you can use. One of them, for example, here is called Mimikatz. And if you're not familiar with Mimikatz, what it does, it's a program, a separate program that somebody wrote several years back that basically tries to grab credentials out of memory. That was turned into a Metasploit module, so you can just type load Mimikatz, and it'll give you several additional commands that you can type. If I type in Kerberos here after I've loaded Mimikatz, it's going to try to dump any plain text Kerberos passwords that are in the system. Again, Windows XP, this works flawlessly. Windows 8.1, not so well. If you get to system level, it's a little bit easier. Different parts of it work better than others. There's a number of other plugins. Incognito tries to steal and manipulate Windows authorization tokens. There's a plugin called LAN attacks, which actually lets you set up a DHCP server so that people, so you can basically change the information that people have. That can be useful for giving them fake DNS information and whatnot. There's a sniffer plugin that runs a packet capture on the local network, and then so you can retrieve that information and see what's going on. A number of different things. There's also a plugin called Kiwi. If you're familiar with Mimikatz, there was a follow-up release called Mimikatz 2.0, and there's a plugin called Kiwi that implements that. So moving on, we talked a little bit, I just briefly talked about auxiliary modules. Like I said, there's a lot of auxiliary modules. They basically do one of three things. They either do sniffing of some kind, they do scanning a network to try to find something, they do fuzzing. The most, I would say probably 90% of the ones that I use are all scanning related. For example, there's just several examples here. The Tomcat Manager login, that basically looks for Tomcat managers on web servers, especially ones that have the default credentials so that you can log in directly. It looks for web server, the DIR listing looks for web servers that have directory listing enabled by default. VNC none auth searches for obviously VNC servers that have no username or password, or it's default or whatever. So several different options there. MSSQL exec is a fun one. If you have credentials to a SQL server, what this does is actually tries to run the XP command shell procedure. And if you're not familiar with that, it's a SQL procedure that runs on the server that actually allows you to run Windows commands on the host itself. So if you have credentials into the web or into the SQL server, you can run XP command shell to actually then compromise the host underlying. So with this module, you can actually do that, deploy your own Meterpreter session, and compromise it that way. There are a number of non-attack uses also. For instance, SSH version scans the local network, or you can give it a range of IPs, and it'll provide you with the different versions of SSH that are out there. IPMI version is another good one. A lot of people have the baseband IPMI systems that either have default credentials or that are improperly configured. A lot of times people don't even know those are running on the system. They just plug in the server and get going and never go in and disable that. So this scanner can be useful for finding those types of things. SNMP login does a really good job of finding SNMP default community strings and whatnot, or finding systems of any kind that allow SNMP so that you can communicate with those. All of these scanners, like I mentioned before, are very target specific, and they're not as noisy as just running a generic vulnerability scan or a full out port scan. These are ways that you can kind of search for specific things and still maintain some level of quietness, I guess, sneakiness. So where do we go from here? What do you do? Hopefully this has given you some idea of what Metasploit is and what you can do with it. Hopefully you're sitting here thinking, if you've never touched it before, you're thinking, man, I need to go get this and give it a shot. If you've played with it some and just kind of struggled with where to go, maybe this has given you some ideas of how to get started. The first thing that you need to do is set up a lab of some kind. If this is one victim machine and one attacker machine, great. If you can set up different OSs and different vulnerable systems, even better. When you're playing with stuff like this, the more different types of systems you can get, the better it is. Different types of Windows systems, some patched, some unpatched, different Linux systems. There's a lot of virtual machines out there that you can download that have systems running on them. Most of them are unpatched, just because most people don't keep the current version of their VM patched. You have to download it and patch it yourself. So that's a great way to find some vulnerable machines. Rapid7 had actually, as part of Metasploit, they built a tool called Metasploitable. And Metasploitable has a number of different vulnerabilities on it that you can use to as kind of a teaching tool to attack. There's a Offensive Security has some online training that they've put together, Metasploit Unleashed training. It's training, but it's really more documentation. They walk through all the different commands and what they do and show you the different things that are available. That's very useful as a reference. And then Rapid7 also has some great reference pages for each of the commands. For the Offensive Security stuff, all they request is that you make a donation to Hackers for Charity. They don't get any profit from that. They just provide that as a free resource to the community. There's also a great book called Metasploit, the Penetration Tester's Guide. It's available on Amazon. Dave Kennedy and several other folks. The only thing is you're not likely to find a used version of this for much cheaper. I'm a pretty big fan of getting cheap used books on Amazon, but this is one of those ones that when people buy it, they tend to keep it. So it's definitely worth the $35 if you're going to use Metasploit very much. And then of course there's tons of videos on YouTube and Vimeo and different blog posts. Just about anything that you can think of wanting to try with Metasploit, you can search Google and find people that have demonstrated how to do it. The biggest thing is just to get in there and try. So just a couple of things to leave you with. I had a shop teacher in high school who always said, measure twice, cut once. Measure twice, cut once. You know, everybody's probably heard that. You always want to know what should happen before you do it. You want to know, you want to make, like I talked before, I always type show options. Every time I set something, I type show options again and make sure it's set correctly. Before I click or type exploit, I always click show options because I want to know for sure, did I set this up right? Is it going to do what I want it to do? You never want to be in this situation where you have to apologize for crashing a system that you didn't even mean to attack in the first place. Never practice in production. If you're not sure how something works or how reliable it is or what it does, set up a lab system and test it there first. Get permission. This is straightforward. Nobody looks good in an orange jumpsuit. I don't want to have to meet you at a conference and you say, yeah, I did 2 years in prison because I went and tried what you told me to on my employer's network and then they didn't like it. So always have signed permission if you're doing this on a network that you don't own. And then I just kind of wanted to give a plug. In about 2 weeks, we're going to have another webinar. It's called Beyond Shell. And basically the idea is, okay, so we've done what we did today. We have shell access on a system. Where do we go from there? What can we do? What are some of the more advanced features of Metasploit that we can use in a penetration testing situation? This is going to be a 2-hour webinar. It's from 2 to 4 p.m. Eastern, and we do charge $25 for the 2-hour webinars. So I think you'll find that to be worth it. So with that said, I know this is I briefly rushed through a lot of things, but does anybody have any questions? And while we're waiting here and see if anybody says anything, I will just mention, I said before at the beginning, at Secure Ideas, we put a lot of focus and a lot of attention into training, into educating both our customers and consumers and just the InfoSec community in general. We do a lot of work with open source projects, and our goal is just to help everybody out. If you have questions, by all means, please shoot me an email there. You've got my Twitter handle. We would love to work with you if you are in need of any kind of security consulting services or penetration tests. You can contact me for that as well. But other than that, that pretty much finishes up the presentation. I will stay on for maybe 5 or 10 minutes in case somebody else has any questions. But other than that, enjoy the rest of your afternoon, guys, and maybe I'll see you at DEF CON.